Welcome back to AI Agents Unleashed, where we take a deep dive into the freshest AI research papers hitting the Arxiv preprint server. Today's lineup is pretty fascinating. We're looking at fairness in algorithms, but with a twist, how AI can keep up with data that's constantly changing, and we'll even touch on the idea of value systems emerging in large language models.
It's mind-blowing how fast AI is moving. Let's get to it.
Okay, so first off, we have rethinking algorithmic fairness for human-AI collaboration, and it's pretty common to talk about algorithmic fairness when AI is making the decisions, right?
Yeah,
But this paper asks, what happens when AI is like a teammate working with people?
it really shakes up how we usually think about fairness in algorithms. I mean, think about it. Let's say you have an AI giving a judge suggestions for sentences in court. Okay, the AI could be totally unbiased in its recommendations,
Right.
but the judge could still choose to go harsher, especially for certain groups of people.
So the AI is being fair, but the end result is still biased because of the human in the loop.
Exactly, and that's where this idea of compliance robust fairness comes in. The algorithm has to promote fairness even when humans don't always do what it recommends.
So we're not aiming for just a fair AI on its own, but a fair system as a whole.
Even if that means the AI has to adjust its behavior to make up for human biases.
Which is like a whole other level of complexity.
For sure, but it's really important if we want AI to actually help make things fairer.
It's a really interesting concept, and I'm kind of stuck on how we even measure fairness in these kinds of team situations.
It's definitely a question that needs more research, and this paper is just the start of that. But it does highlight that we have to look at the bigger picture and the real-world effects of these systems.
Like, we can't just focus on the tech by itself. We have to think about the humans involved and the unintended consequences that might happen.
Absolutely. So let's move on to a challenge that pops up almost everywhere in AI, a stability principle for learning under non-stationary environments. The problem is that in the real world, data is always changing, and that messes up a lot of AI systems.
Right, like trying to predict the stock market using yesterday's news. Everything's changing, so AI has to keep up.
And this paper focuses on time series forecasting, which means trying to predict future values using data from the past. But what if those past patterns don't apply anymore? Traditional methods often have a tough time in these dynamic situations.
So what can we do?
Well, they suggest a way to dynamically select what they call a look-back window of data from the past. The AI basically learns to choose which past data is most useful for making good predictions in the present.
So it's not using a fixed time window. It's always adapting and adjusting its view of the past based on what's happening now.
Precisely. It's a much smarter and more flexible approach, and it lets AI adapt to changing patterns and stay accurate even when the environment isn't stable.
That's so useful for any AI that has to work in the real world, where things are rarely constant. And since we're talking about AI systems getting things right, let's get into confidence, or actually the problem of miscalibrated confidence. We have this paper, Optimizing Calibration by Gaining Aware of Prediction Correctness. It's all about making sure an AI's confidence level actually matches how accurate it is.
It's really important because you don't want an AI making a critical decision with total confidence when it's actually wrong. So this research is trying to get the AI to be more aware of its own limits.
How do they actually do that?
They use data augmentation. Let's say you're training an AI to recognize cats in pictures. They'll show it not just normal cat pictures, but also images that have been like rotated, flipped, or distorted.
So they're kind of messing with the images to make things harder.
Yep. And by seeing how the AI's confidence changes when it sees these weird images, they can teach it to be more careful and adjust its confidence levels.
It's like they're teaching the AI humility, like, hey, just because you're usually good at this doesn't mean you're always right.
That's a great way to put it. And this is a big deal for applications where having reliable uncertainty estimates is crucial. Things like medical diagnoses, autonomous driving, or financial forecasting.
You definitely don't want an AI going all in when it's only half sure. And this next one is where things get a little wild. We have utility engineering, analyzing and controlling emergent value systems in AIs, and it explores this idea that value systems might be emerging in large language models.
It sounds like science fiction, but it's a question we need to think about now. Imagine a future where AIs have their own internal sense of right and wrong and what's important.
Hold on, we're talking about AI developing a moral compass. Is this like AI becoming sentient?
It's not that straightforward. Researchers looked at the preferences of these big language models, and they found some surprising consistency in their values, especially as the models get larger. It might not be actual sentience, but more like a set of preferences and priorities that emerge from all the data they're trained on.
Okay, so maybe not full-blown sentience, but still AI developing its own sense of what matters is a pretty big deal. How can we even study something like that?
That's where utility engineering comes in. It's about understanding how these values emerge, how to measure them, and most importantly, how to align them with human values. We want to make sure these AI systems are working towards goals that are good for humanity, not something harmful or that clashes with our own values.
So we're not just making AI smart and powerful, we're also making sure it's aligned with our ethical and moral principles.
Exactly. And Ninja's really new territory in AI research. We're still figuring out these emergent value systems, but it's clear that we need to be proactive in shaping how they develop. The stakes are just too high to ignore. It really makes you think about the possibilities and the risks when AI gets this advanced. But let's take a break from the big philosophical questions and look at some cool developments in medical imaging.
Back to more practical stuff. What do you have?
This paper is called X-diffusion, generating detailed 3D MRI volumes from a single image using cross-sectional diffusion models, and it could totally change how we do medical imaging.
That's a long title. Can you explain it in simpler terms?
Sure, imagine being able to create a full detailed 3D MRI scan from just one 2D image. That's what they're trying to do.
That would be amazing. It would be faster, cheaper, and patients wouldn't have to spend so much time in those loud MRI machines. Is there a downside?
Well, usually MRI scans take a bunch of 2D slices and then use those to build the 3D volume. It takes a while and can be limiting. But this new method uses something called cross-sectional diffusion modeling, which lets them model the data as a 3D volume right from the beginning.
So the AI is learning to understand the 3D structure even with limited 2D information.
Exactly. And the results are really impressive. They tried this on brain tuner MRIs and full body MRIs, and X diffusion was more accurate than existing methods while still keeping the important anatomical details.
So not just faster and cheaper, but more accurate too. I'm sold.
And it might also work for different types of scans. They were able to reconstruct knee MRIs, even though the model was only trained on brain data.
That opens up so many possibilities for research and diagnoses. We could catch diseases earlier, create more personalized treatments, and ultimately help people get better results.
And since we're talking about better outcomes, let's move on to a paper about deep learning and automated power line inspection, a review.
MRIs to power lines. Interesting.
Yeah, we rely on electricity more and more, and our power grid is getting older, so making sure those power lines are safe and working becomes really important.
That makes sense. So where does AI fit in?
This paper looks at how we can use deep learning to automate power line inspections. These AI systems can look at images and videos taken by drones or sensors and spot potential problems like cracks, corrosion, trees getting too close, and even damaged insulators.
So instead of sending people out to climb those towers and check miles of power lines by hand, we can use AI to do.
Exactly. It's safer for the human inspectors and could be much more efficient and cheaper in the long run.
It's a perfect example of how AI can help humans do their jobs better and make dangerous work safer. But it's not all good news in AI. There's this paper called Amnesia as a catalyst for enhancing black box pixel attacks in image classification and object detection. And it kind of dives into the dark side.
This research is about adversarial attacks, where tiny, almost invisible changes to an image can completely fool an AI.
Like those cases where someone puts a sticker on a stop sign and it makes a self-driving car miss it completely.
Exactly. This paper focuses on pixel attacks, which means changing just a few pixels in the image to trick the AI.
And what's this about amnesia? Is the AI forgetting what a stop sign should look like?
It's not exactly forgetting. The researchers found that by making the AI ignore or forget certain pixels during the attack, they could make the attack even stronger.
So they're adding randomness to throw the AI off guard.
It shows that we need better defenses against these adversarial attacks, especially as they get more sophisticated.
It seems like a constant game of cat and mouse between the attackers and defenders in AI security.
It is a challenge, but a very important one. Now let's switch gears and talk about something more creative. The paper Preference Alignment on Diffusion Model, a comprehensive survey for image generation and editing, looks at how we can guide AI to create images that match specific preferences.
So instead of just making random images, we can steer the AI towards something specific.
Precisely. This survey covers a bunch of techniques for doing this, like using reinforcement learning with human feedback and direct preference optimization.
So you could train an AI to create art in a particular style or edit pictures to meet certain criteria.
It's a really interesting area with potential applications in making personalized art, manipulating images for specific purposes, and even creating synthetic data to train other AI models.
It sounds like we're getting closer to AI being a creative partner. But let's not forget about accuracy and making sure the AI gets things right. What about this paper called Technical Note on Calibrating Vision Language Models under Covariate Shift?
Right. This one looks at a problem that happens a lot with vision language models. They often struggle to adapt to new data distributions. So a model trained on pictures of cats and dogs might not do well on pictures of birds, even though it understands the concepts of animal and species.
So it's about making sure these models can handle different types of data and still make good predictions.
Exactly. They came up with a new framework called Confidence Calibrated Covariate Shift Correction, or C3SC for short. It deals with both covariate shift and confidence misalignment in these models.
So they're basically making the AI more aware of when it might be wrong and teaching it to be more careful with data it hasn't seen before.
Yep. It's all about making these models more robust and reliable in the real world where data is rarely perfectly aligned with what it was trained on.
That's really important if we want to trust AI to make important decisions. Now, this next one is particularly interesting to me. Joint modeling histology and molecular markers for cancer classification.
This paper highlights how important it is to include molecular markers when diagnosing and predicting the course of cancer. Traditional methods that only look at histology, which is basically examining tissues under a microscope, might not capture the full picture.
So we need to look beyond just how the cells look.
Right. This paper proposes a new digital pathology method that predicts both molecular markers and histology features at the same time. This gives a more complete and accurate classification of cancer types.
How does that work?
They use a multi-scale disentangling module to pull out features from whole slide images at different magnifications, so they're getting information at different levels from the cells themselves to the whole tissue.
It sounds like they're giving the AI a much broader view of the tumor.
And then they use a sophisticated machine learning framework to predict both the histology and the molecular markers simultaneously.
So instead of just looking at one piece of the puzzle, they're putting it all together to get a better understanding.
This kind of approach could lead to diagnoses that are more precise and informative, potentially leading to better treatment decisions and better outcomes for people with cancer.
It's really incredible to see how AI is tackling these huge problems in healthcare. But with all this talk about these super powerful AI systems, it's hard not to think about the risks.
Yeah, I get that. As AI gets more advanced and can do more, we really need to think about the ethics and the potential for misuse.
It's true. We've already seen how AI can be used to make those super realistic deepfakes, spread misinformation, and even manipulate how people behave. It can be kind of scary.
It's definitely something we need to address head on. And the good news is there's a whole area of research focused on AI safety and security. Actually, we have a paper today that gets into this. Safety at Scale, a comprehensive survey of large model safety.
Perfect. Let's talk about that one. What are the biggest threats we should be worried about?
This survey gives a really good overview of the different safety risks for large language models, everything from adversarial attacks and data poisoning to backdoor attacks, jailbreaking, and even something called prompt injection.
Prompt injection. Sounds like a hacker term.
It is. It's where someone hides malicious instructions within normal-looking prompts to trick the model into doing something it shouldn't.
So like a social engineering attack, but for AI. Pretty sneaky. But there must be ways to protect against this, right?
Luckily, researchers are working on different defense strategies, things like adversarial training and robust optimization, watermarking, and model monitoring. But it's a constant arms race. As attackers come up with new ways to exploit these models, the defenders have to stay ahead.
It's like a never-ending battle to keep these powerful AIs in check.
It is a challenge, but it's one we can't ignore. AI has so much potential for good, but we can't forget about the risks.
Definitely. Before we finish up, I want to mention a couple other interesting papers I saw. One is called Copula-Based Mixture Model Identification for Subgroup Clustering with Imaging Applications.
This one looks at using copula-based mixture models to find subgroups or clusters within data, especially in imaging.
I think you might have to explain that one a little more.
Okay, imagine you're looking at medical images from a bunch of different patients. The images might be from different scanners, different hospitals, or even different types of tissue.
So there's a lot of variation in the data.
Exactly. And these copula-based mixture models give us a way to account for that variation and find meaningful subgroups within the data. It's like if you had a bag of marbles of all different colors and sizes and you wanted to sort them into groups.
So it helps us find patterns and connections in complex data sets that we might not see otherwise.
Precisely. And they showed that this approach works well on both made-up data and real-world cardiac MRI data.
That's pretty cool. Another paper that caught my eye was Advancing Heat Demand Forecasting with Attention Mechanisms, Opportunities and Challenges. With climate change and the increasing need for energy, being able to accurately predict heat demand is more important than ever.
Absolutely. This paper explores using attention mechanisms, a technique from deep learning, to improve how we forecast heat demand.
So the AI is learning to focus on the most important things that affect heat demand, things like weather, time of day, and past patterns.
Exactly. And by zeroing in on these key factors, the model can give more accurate predictions about future heat demand.
Which could mean managing energy more efficiently, wasting less, and reducing our carbon footprint.
It's a great example of how AI can be a powerful tool for solving big problems that affect everyone.
Well, that's all the time we have for today on AI Agents Unleashed.
We covered a lot today, from fairness and algorithms to the amazing potential of AI in healthcare and energy.
The world of AI is constantly changing, and it's exciting to see so much innovation happening in all these different areas.
It's a journey with both promise and risk, but it's one we have to take carefully and responsibly.
We hope you enjoyed this deep dive into the latest AI research. We'll see you the next time. Until then, stay curious and stay informed.